Okay, so as stated, all we're going to be doing today is more practice on confidence intervals and probability like we did yesterday on the difference between two proportions. Okay, so this one is very much like the goldfish. It's the sampling distribution of, the difference in proportions and a probability question from it. So let's take a look. Okay, so if we're going to describe a distribution, okay, that's center, unusual features, shape, and spread. Since it says describe the whole sampling distribution, whereas before it said just describe the shape. Remember, please, that if you're ever told to describe a distribution, then we're looking for cuss and BS, right? Center, unusual features, shape, and spread. Okay, so the center, very, very easy. The center is just going to be A minus B, the percentages that you're given. Okay, so that's 0.6 minus 0.48. Okay, and that's just 0.12 or 12% basically. Okay, very, very easy. Okay, and that's the mean, and you can actually state that that is the mean of p hat, running out of room, p hat A minus p hat B. And we really should make sure that we're using the proper notation because that is the mean of the sampling distribution of those differences. Okay, unusual features we really can't talk about. We don't know if there are going to be any gaps or any outliers, but if I'm taking 80 beads from each of them, then I've got a sample that's going to be pretty normal, approximately normal. So we can say that there's going to be no gaps. We can go ahead and just say that there's no gaps or assume no unusual features because we've taken a big enough sample size in order to guarantee that our shape is going to be approximately normal. Okay, so shape, in this case, this is where we do our check for normality. So we need 60% of 80, right? And 60% of 80 should be 48, right? And that's definitely bigger than 10, so we're good. That's our successes. And then 40% of 80 should also be bigger than 10. So 80, not of 8. And that should equal, what, 32? And that's definitely bigger than 10. Okay, we could probably need some more room in here. So I'm going to slide that one down. Okay. And now we need to do the other piece. Okay, so the other one has 48%. So, 48% of 80. Let's see. That's going to be, wow, what? 40 minus 1.6, 38.4. Okay, and that's definitely bigger than 10. It's okay that it's not a whole number because we're just going by the percentages we're given. Okay, and then the 52% of 80. Okay, and that's going to be 41.6, and that's definitely bigger than 10. So all of my successes and failures are bigger than 10, like they're supposed to be. So we can then say that the shape is approximately normal. Okay, now the really fun part is now we're going to have to do the standard deviation because that's going to be our measure of spread. Okay, and that's that really big, what do you want to call it? That really big square root, right, that we need to deal with. Okay, so I'm going to let you start setting that up, and then I'm going to go grab my iPad since I don't have my calculator so that I can go and use Desmos and actually calculate this. Okay, so as far as being set up, it's going to be, since the first one is 0.60 or 60%, it's going to be 0.60 times 0.40, right? 60% success, 40% failure, divided by 80. And then inside that square root should also be the 0.48 and the 0.52. And that should also be divided by 80, since we're taking 80 from each one. Okay, so let me get this in Desmos, and hopefully my math isn't, going wonky. Okay, so 0.6 times 0.4 all over 80 plus 0.48 times 0.52 all over 80. I'm getting 0.078. Okay, and if we have the mean and the standard deviation, then we should be able to do the probability question that comes next, because we have our mean and we have our standard deviation, and all we need now is a piece, right? That's, our statistic minus our parameter. Well, our parameter is 12%. Our standard deviation is 0.078, so let's figure out what our pieces that we're interested in. The probability that the proportion of red beads that you select from bin B is higher than the proportion of red beads you select from bin A. Okay, so I'm subtracting B from A, so it's A minus B, and if B is bigger than A, then my answer when I subtract is going to be less than 0. So 0 is going to end up being what it is that we're asking for. We want the probability that it's going to be less than 0. Because if I subtract a bigger number from a smaller one, I should get a 0. Okay, so that being said, 0 minus 12% divided by the 0.078 standard deviation that we got should give you what for your z-score? Let's see. Divided by negative 1.54 is what I'm getting. Okay, so then we have to go look up negative 1.54, and since it's a less than, we don't have to subtract, which is nice. So let me go look up a z-table. Again, I'm doing this on my iPad because I forgot my stuff. So negative 1.54 is 0.0618. So going back to what we're supposed to do, the probability that z is less than negative 1.54, and we just look that up. And again, that is 0.0618. Okay, so there is if we're going to actually answer this in full statement, 6.18% chance that the difference bin A minus bin B will be less than 0. Or that you could say that the 6.18% chance that bin A has a higher proportion than the bin B has a higher proportion than bin A, which would be another way to answer the same question. And bin A. So those are basically, it's the same exact answer. This way I'm showing that I'm subtracting and getting less than 0. This way I'm stating basically what that means. It means that bin B is higher. Okay, So that's just a probability question based on the difference of a proportion. And that's real popular for like the first couple of parts of an open response question, and then they get into either the confidence interval or the inference test. Okay, so let's try another confidence interval. I think I put 2 extra examples on here for today, and I may just do the first one and then assign you the second one as homework. I have not heard any questions yet, or gotten any remind questions yet about the homework that I told you to look at tonight. And since I won't be, teaching you live today, you need to make sure that you're sending me those questions if you're getting stuck. All right, so this is going to be a state plan to conclude. We know that. Okay, so in 2008, in November, right before the presidential election, a newspaper conducted a poll of residents and found that 120 out of an SRS of 250 men and 132 out of an SRS of 240 women intended to vote for Obama. Okay, so we're going to do a 95% confidence interval for the difference in proportion of men and women. And since they're telling us men and women, then that is the way that we are going to subtract. Okay, so what are we doing for our state? We are estimating I'm going to capitalize what you should be having, true difference. Ooh, 2 F's would be good. True difference in proportion of, you could say people that intended, because we don't know if they actually did. True difference in proportion of people that intended to vote for Obama, and then we have to state which direction we are actually subtracting in. Again, I'm doing this, the emphasis on what you absolutely have to make your state complete. And I actually probably should have capitalized estimating as well, because this is not a ho-ha, and we are not determining or finding, because you're not finding a definite answer. Remember, you're giving an interval of answers where the true proportion could possibly be. And remember, if we're doing it 95%, we're only going to actually capture it 95% of the time, right? That actual true proportion. So you can't say that you're finding or determining or solving for whatever. It is estimating. That's what a confidence interval does. It estimates. Okay, so do this in a different color. Plan. All right. Random SRS given, right? It says it for both of them. SRS, simple random sample. All right. Independent. Dependent. Can't spell today. Still can't spell. Okay, independent. All right, so there are more than 250 times 10 men and 240 times 10 women in a medium-sized city. 250 and 240. Okay, so now we do normal. And this is all 4 of them, guys. Again, successes and failures. So 120 greater than 10. And if we subtract 120 from 250, then we get 130 is bigger than 10. All right, and then we go for the women. For the women, 132 is greater than 10. And 108, right? It's greater than 10. And again, up underneath of it, you can just put success and failure. Please make sure you put the all-important, approximately normal. And yes, I capitalized the word normal because it is in statistics a proper term. which is why we're not allowed to say something is normal. We're allowed to say it's approximately normal unless we're told it's normal. Okay, so now we got to do the do. All right, so the difference in the statistics. Okay, so I'm going to go ahead and get the decimals to begin with to make life easier. So 120 out of 250. Okay, so 120, nope, let's try that again. 120 divided by 250 is 0.48. That makes life easier. That's the men, I think. Yeah. And 132 out of 240. Divided by 240. It's 0.55. Okay, so since we're subtracting women minus men, okay, minus 0.48, there's our statistic, right? We're doing a 95% proportion, so, and I'm just going to put plus or minus on that. I'm still going to use 1.96 just because I know if I forget the 2 on the empirical rule, I can always look on the bottom of that t-distribution. Remember, that's got all of your z confidence interval levels that you need. Okay, and then the really big honkin' standard deviation. All right, so now that I know my 2 pieces, it makes life easier. So 0.55 for the women times 0.45. And this actually doesn't matter if you screw up and put the men first because you're adding them anyway. So it's not like it's a big deal. In this one, for your statistic, it matters what order. And there were 240 women. Okay. And then we're going to add the men's statistics, and that would be 0.48. Okay, times 0.52. Right, divided by 250. And we need to figure out whatever that is so that we can actually do our do part. Our statistic is going to simplify down, thank goodness, to a nice small number. Okay, so plus or minus 1.96 times this big thing. And you should be putting this in your calculators now. All right, let's see. That's a fraction. 0.55 times 0.45 all over 240, right? Okay. Plus fraction 0.48 times 0.52 all over 250. And I'm getting 0.045 for mine. 0.045. And if I wanted to let it keep going and have the computer or the Desmos hold on to it, it's going to be a little bit more difficult. For you, it actually should be pretty easy. Because I can just, well, I guess I could actually multiply 1.96. Gives me 0.088. So that would definitely be a rounded, because if I multiplied that by 1.96, well, actually that might be right. So 0.07 plus or minus 0.088. Right? Okay, rounded again. So my interval is going to end up being 0.07 minus 0.088 is negative 0.018. And then the positive 0.07 plus 0.088 is going to be 0.158. Interestingly enough, on that one, 0 is actually contained within that interval. So if we were to go back and, we might later go back and run an inference test to see if there's an actual difference between them. Being that 0 is in that because your interval goes from negative to positive, you would actually end up failing to reject because you wouldn't be able to prove that there is a difference between these men and women, because 0 happens to be in your interval. That's why we use intervals to check inference tests. So there's my interval, and we should be able to write out our conclusion. Let's see if I can get that over here. There we go. We are 95% confident that the interval from negative 0.1, 0.018 to 0.158 captures the true difference in proportion of people who intend to vote for BAMA. There we go. Women minus men. Okay, so practice for today. I'm going to go ahead and actually let you do this one as a homework assignment for tonight. I do want you to submit this, so you can either submit it as a picture from your notes. You can just basically send it back to me, or you can do it on paper and submit it as a picture. I can open up an assignment in Canvas. If y'all tell me, if you send me like a remind message and tell me you want me to open it up as an assignment in Canvas, I can actually post this page as a PDF in Canvas and you can write on it. Either or, but I want to go ahead and assign this one as a homework assignment. And again, keep looking at those same problems. I won't give you any more problems until we actually run an inference test on this. And again, that's for practice. Please be sure that you are looking through the chapter and the notes that I sent in Canvas already for those vocabulary terms, because that is what y'all have been struggling with. Okay, so please do that. I will talk to you later.